In this financial mathematics lesson, we're going to have a look at deviations on the formulas. The future value formula determines the value of an account immediately after the last payment has been made. So normally you would start making your first payment at the end of the first period, and then you will continue like this, making your final or last payment at the end of the last period. The future value formula will then determine the value of your account immediately after you've made that final payment. There are, however, instances where the last payment is made before the end of the account. This means there won't be another payment at the end of the last period. Another option is annuities paid in advance, and this means you will make a payment at the beginning of each month or each period. This means your first payment will be at the beginning of the first period at T0, and your last payment will be at the beginning of the last period. And at the end of the last period, no extra payment will be made. The future value formula will then give you the value of the account right after your final payment, and this value will then earn interest for the last period without any extra payments being made. Alex invests 1,000 Rand per month for 4 years. His first payment is made immediately, and his last payment is made 1 month before the end of the 4 years. Here they could have also said that his payments are made in advance because his first payment is made at the beginning of the first month and his last payment at the beginning of the last month. The interest rate is 9.5% per annum compounded monthly. How much money will he have at the end of the 4 years? Because Alex invests money for 4 years worth of months, the last period will be after 4 years worth of months, which is 48 months. His first payment is made immediately, so at T0, and his last payment is made 1 month before the end of the 4 years, so that's at T47. The future value formula can then determine the value of this account straight after the last payment at 47 months. This whole amount then still receives interest for the last month until the end of the 48 months. And because this whole formula will give us the value of the account after 47 months, we can say that this whole value will now still receive 1 month's worth of interest up to month 48. And now we can substitute into the formula. Our X is our monthly payment of 1,000 Rand, and this will receive interest of 9.5% compounded monthly. Our number of payments, because he paid up to the 47th month, but he started immediately at T0 already, there will be 48 payments. And this whole value will then still receive the interest of 9.5% compounded monthly for 1 extra month. And when you determine this on your calculator, you will see that at the end of the 4 years, this account will be worth 58,577 Rand and 77 cents. A second deviation on the formulas is when the repayment on a loan starts later than normal. This is also called a payment holiday. The present value formula is based on the fact that repayment starts 1 period after the loan has been granted. So on our timeline, the present value will be determined at T0 if the first payment is made 1 period after that at T1. But it can happen that you start repaying your loan at a later stage. An example of this is when you buy a car. Car dealers often advertise a payment holiday and say you can buy the car now, but only start paying at a later stage. In our example, your first payment is only in 6 months. But what they do not tell you is that even though you do not need to start paying, they are going to start charging you interest on the loan. So for the first 5 months, before you start paying on the 6th month, there will be interest added to your account. So for the first 5 months, it's as if there's one amount that receives interest for 5 months. Then the present value formula starts working 1 month before you start paying, and that means in our example, the present value formula starts at T5. Therefore, you need to realize that when you want to use the present value formula in this case, you need to add the 5-month interest to the present value in the formula. In the next example, you will see how this is done. Example 2. A loan of 500,000 Rand is repaid by means of equal quarterly payments, starting 9 months after the loan is granted, and the last payment is made 5 years after the loan is granted. The interest rate is 8% per annum compounded quarterly. Calculate the quarterly payments. Here, a loan of 500,000 Rand is repaid quarterly within 5 years. 5 years worth of quarters is 5 times 4, and that means we have 20 quarters. However, the first payment is only made 9 months after the loan has been granted. Here it is important to remember that quarterly means every 3 months. The given 9 months then means that the first payment is made 3 quarters after the loan has been granted. Because the first payment is only made after 3 quarters, our present value formula only starts working at the end of the second quarter. During the first 2 quarters, however, there will be interest added to that original 500,000 Rand. So when we now go and substitute into our present value formula, you need to realize that the present value is not only the 500,000 Rand anymore, but also the interest of 8% compounded quarterly for the first 2 quarters. And that will form our present value in the formula. On the right, we want to calculate the payment, and we know the interest is once again 8% compounded quarterly. And now we need to determine the number of payments that are made. Normally, over 20 periods, 20 payments will be made, but in this case, the first payment as well as the second payment was missed, and only at T3 the first payment was made. You can also remember that the number of payments is always the last payment minus the first payment plus 1, and that means we will have 18 payments. To solve x, I'm going to take the value on the left and then multiply that with the I that is divided on the right, and then the bracket that is multiplied to x will be divided. The quarterly payment will then be 34,698 Rand and 43 cents.